Now we are discussing the second rearrangement reaction, that is the Hoffmann rearrangement. See, in Hoffmann rearrangement there is a conversion of unsubstituted amine into the amine. So we can write here in this Hoffmann rearrangement, what is conversion here? Amine, that is we can say here the primary amine to the amine, I write here the structure. See, this is R C double bond O NH2. When this amide react with bromine, in a presence of strong base, then it will be give us amine RNH2 primary amine. This is the primary amine which form here, and in this case we got the byproduct Na2CO3 plus Na2CO3 plus NaBr. Now we can see here. So here is the water also removed because hydroxide here, so it gives us the water. If we observe this conversion, then we can see here in the conversion of amide to amine, there is used bromine and sodium hydroxide, which give us the hypobromous acid firstly. So what is hypobromous acid? NaOBr is a hypobromous acid. When which reacts with the amide, then there is a firstly bromination, and then when this bromine will be removed, there is formation of isocyanic intermediate, and this unstable isocyanic intermediate in presence of strong base, it gives us the amine. So this reaction is called as a Hoffmann rearrangement or Hoffmann bromamide reaction, or somewhere it is called as a Hoffmann bromamide elimination reaction. See, in this conversion amide to primary amide, so we can simply remember this thing, this carbonyl will be removed here, and this NH2 will attach to this R, and we got here the amide. Let us see here the mechanism of this reaction. Let us see here the mechanism of this reaction. So simply we can write here, this is R, this is C double bond O, and this is the NH2. So this NH2 is written in this way for simplification of the mechanism. When this amide firstly react with sodium hydroxide, then this hydroxyl anion will take this hydrogen, take this proton from this amide, and there will be formation of the negative charge on the nitrogen, and we got the structure like this. This is the negative charge, this is the NH. When this react with further with bromine, this negative charge takes this bromine here, and this one bromine will be removed, and we got here the structure RC double bond O. This is the nitrogen, this is hydrogen here, and this is the bromine here. So this is nothing but the N-bromoamide. This is nothing but the N-bromoamide. When this N-bromoamide further react with one another molecule of a base, then this hydroxyl ion by absorbing this proton, there will be formation of negative charge on this nitrogen, and we got here this is R, this is C double bond O, this is nitrogen, and this is the bromine. This is the bromine. Now this nitrogen having negative charge. Now see, as this nitrogen having negative charge, it will be very reactive species. This negative charge makes here double bond. This double bond will open here on oxygen, and oxygen having now negative charge. This negative charge again makes here double bond, and by forming this double bond, this all whole alkyl group will be transferred to the nitrogen, and this bromine will be removed, and we got here the isocyanate intermediate C. So we can write from the mechanism from this oxygen. This is oxygen here. This is oxygen attached to carbon by double bond. This carbon attached to this nitrogen by double bond. This nitrogen attached to this R group. So this is the isocyanate intermediate. This is isocyanate intermediate. This is the isocyanate intermediate. Now, as we see here, in this reaction we have used here the base. So we can see here this OH minus now, which is comes from the base, will attach to this carbon, and this bond will here open, and the nitrogen having negative charge, so therefore this is oxygen, this is double bond carbon, this is this carbon having the OH here, this is the nitrogen which having negative charge here, and this nitrogen having here again R. As we use here the water, water is also formed here. See, this nitrogen will take the proton from this water molecule, and again this OH will be removed here, and we got here this is oxygen with double bond carbon, this is OH here, this is NH here, and this is RH here. So in this case we can also write, see these absorptions of this proton from here, this bond will be shift here, and this bond will be shift here, and this bond will be takes the proton. So there is a formation of C. This is the R, and this is the NH2. You write this RNH2 in such a way. This is the RNH2, and there is a formation of carbon dioxide. Will be equal here. So this is the primary amine. This is the primary amine. So in Hoffmann rearrangement, we have convert here amine. We have convert here amine to the primary amine. Amine to the primary amine. Then in this reaction, we have to keep in mind. We have to remember one thing. We convert here only amide to amine. But which amide that you take here, you can observe that take here the unsubstituted amide. Unsubstituted amide. When we take N monosubstituted amide or N disubstituted amide, for example, N-methyl amide or N-dimethyl amide, then this reaction does not work up, because you can see here both these hydrogen will be absorbed by the base here. So in first stage, this hydrogen will be absorbed here, and in second stage, in third stage, this hydrogen will be absorbed here, and there is a formation of negative charge on the nitrogen. If we take here monosubstituted amide, monosubstituted amide, then this step will be proceed here, but this step of this absorption of this R group will be not here, and hence the next step will be not happen here, which does not give the primary amide. When you take here the disubstituted amide here, so this first stage will be not happen here. The adjustments of proton will be not here, and hence this reaction will be not complete here. So very simple, you can say that any substituted amide, either it will be monosubstituted or either it will be disubstituted. Hoffmann rearrangement is not work up, or Hoffmann rearrangement is not found in the N substituted amides. Then let us discuss now the examples of Hoffmann rearrangement. See, these are the two examples that we have to discuss here, that we have to find out the product of this reaction. So from these two examples we can judge these examples belongs to the Hoffmann rearrangement. Why these examples belongs to the Hoffmann rearrangement? Because here the reagent is given the amide, reactant is given the amide, and reagent is the bromine in presence of sodium hydroxide. So therefore we can judge these are the examples from the Hoffmann rearrangement. Now see here what happened. So we saw here the first example. So in the first example we can see this hydroxyl ion, that is OH minus, which is comes from the base, it takes the proton from the amide, and there will be formation of negative charge, and we got here the new structure here. See, this is the C double bond O, and this is the N, this is the H. Now this is nitrogen having negative charge, which will be react with the bromine, and on bromination we got here the N-bromoamide. This N-bromoamide will be like this. This is the COOH, this is the C double bond O, this is the N, this is the H, and this N having now bromine. Again, in next step, this base will be take the proton from this amide, and there will be formation of negative charge on the nitrogen. This is the COOH, this is the C double bond O, this is the N, this is the Bi here, and this is having negative charge. This having negative charge. Or we can write this negative charge here. It will be Ag for our mechanism. See, this negative charge will attack here and make here the double bond. This carbon nitrogen double bond get open. Again this carbon, again this negative charge and oxygen will make here the double bond, and all this whole group will be more to nitrogen, and this bromine will be removed. So we can start from this ring, or we can start from this carbon. So we are starting from this 5-membered ring. This is the 5-membered ring. This is COOH. Now this 5-membered ring will attach to this nitrogen. So here is the nitrogen. This nitrogen having double bond, and further attached to the carbon, and this carbon having double bond, and further attached to the oxygen. That is, this is nothing but the isocyanate. Now this isocyanate when becomes in presence, becomes forwarded by the base, then here is the opening this double bond, and there again formation of negative charge on the nitrogen atom. So this nitrogen now having negative charge here, and this is the double bond, carbon double bond, oxygen. Here is the COOH group. Now from water, this nitrogen having takes here the proton, and this hydrogen group will be removed here. So we got here, see, this is the 5-membered ring. This is the COOH. This is the NH here. see this double bond is break here, so here will be the single bond. This NH having C double bond O and C double bond O. Now again one another hydroxyl group will be attached to this one another hydroxyl group will attach to this carbonyl group here, and after attacking this carbonyl group, sorry, here should be, see, when hydroxyl group attach here, then in this case here is the OH here is the OH. Now see, this is the OH here, so this mechanism will be like this. This bond will be shift here, and this bond will be break, and there is a formation of negative charge on hydrogen. We got here the final product. This is our final product. This is the 5-member ring. This is the 5-member ring. This is COOH. This is NH2. Here carbon dioxide will be removed here. So this is our primary amine, which is our final product. So in such a way, we can convert amide to primary amine. Let us discuss now this second example. See, this second example that we are going to discuss here. Very simple. The first step is absorptions of proton by the hydroxyl group. This hydroxyl group will absorb this proton. We got here the negative charge on nitrogen atom. This is the negative charge. This is hydrogen. And further, this negative charge will attack here on bromine. This negative charge will attack here on bromine, and we got here the N-bromoamide. This is the N-bromoamide. This is N, this is bromine, this is hydrogen, N-bromoamide. Or C, at further this again one OH minus this place this hydrogen. There will be formation of negative charge. This negative charge will be written in a such a way. See, this is the double bond, this is nitrogen here, this is the bromine here, and this is the negative charge. Now this negative charge makes here a double bond. This bond will open, and again this bond will E form here, and this pyridine will be migrate to the nitrogen from carbon. This bromine will be more, and here we can write from this pyridine ring, pyridine ring now attached to the nitrogen. This is the nitrogen. This nitrogen now attached to carbon by double bond. This carbon attached now to the. So this isocyanate when it react with water, or this isocyanate will react with the hydroxyl group. See here, this hydroxyl group will be attacked on this carbon. This bond will be open here, and this negative charge takes hydrogen from the water, and we got here. So this is the nitrogen. This is double bond. This is NH now. This is C double bond O, and this C double bond O now having here the OH. Now this hydrogen will shift down nitrogen. This bond will be shift here, and we got here the final product. This is the PDDP. This is the NH2. This is the NH2, and this carbon dioxide will be removed. So very simple. From imide to to primary amide. Sorry, amide to primary amide. This is the amide and this is the primary amide. Friend, so very simple way we can convert here amide to primary amide by the Hoffmann rearrangement. So in this lecture we have discussed two rearrangements. One is the Beckmann rearrangement. In Beckmann rearrangement we convert ketoxide to the amide, and now in Hoffmann rearrangement we convert here the amide to primary amide. In next lecture we are going to discuss, in next lecture we will be discuss the remaining rearrangement. Thank you.